dive into our algebra series. We are going to deal with exponents today, which is a really big day because we have a lot of fun stuff that's going to be happening, including how to start to talk about variables and really the heart of what algebra is. So we're going to have a lot of fun. If you happen to have your handout, go ahead and grab it. It looks like this. If you don't, just grab a notebook and a piece of paper, and we're going to roll down onto the desk, my desk, and we're going to get started. So do you have your pencil? Okay, we're going to start with a game. The game is called Get It to Zero. Okay, so Get It to Zero is the name of the game. So let's see how to play this. So if I write on here 2 plus something equals 0, what's the something that goes in the box? Yeah, this one should not be too hard. 2 plus something. Well, you got to, it's actually plus a. Good, I'm seeing it now. A -2. Good. Okay, wait, how about this one? What if I have a -1 plus something is 0? What goes in the box now? Oh, you're good at this. -1 plus, there's only one number that'll satisfy that, right? Good. How about this one? -5 plus, now instead of the box, I'm going to write x. X means I don't know what it is, but I want to. Okay. What's the only value for this variable x that'll work? -5 plus something equals, yeah, there you go. So x equals 5. So these three little dots mean therefore. So therefore, x must equal 5. Okay, let's do another one. What if I said 2 times x is 0? What does x have to be? Do you remember our properties from before? Identity, 0, distributive property. There were lots of properties, right? 2 times something is 0. What's the only value of x that will work? Yeah, x has to be 0. Good. All right, well, what if I do this? What if I say 1/4 times x is 0? What does x have to be? Yeah, it's still 0, right? Good. Okay. Good, good, good. All right, so I think you've got the idea of that game. Let's try another one. This one's going to be called Get It to 1. Here's 1/2 times something I don't know, and it's equal to 1. What's the only number that's going to work for this? 1/2 times something equals 1. Okay, so if you didn't see this one right off the bat, if I write this like this, does that help? Does that help you? It's the same thing, right? 1 times x is in the numerator, 2 is on the denominator, so I just didn't write the 1 here. Yeah, so any number where the top and bottom is the same, that's going to equal 1. So x equals 2. Good. Okay, let's do another one. How about x, 1/5 x equals 1? What do you think about that one? What's the only value for x that's going to work? Okay, I'll write it like this again if that's helpful. Okay, somebody's wondering, how can I just move the x over here? It's because they're multiplied. It's 1 times x is in the numerator and the 5 is in the denominator. This is the same thing as this term right here. Okay, so we don't have to write the 1 because 1 times x is just x. So that's how I can do that. Okay. Good. X must equal 5. Good. Okay. What if I said, I'm going to give you a couple of them now, and then you tell me the answers to all of them. 2x equals 1. 3x equals 1. Okay. 1/9x equals 1. Okay. Go ahead. You tell me what each one of those has to be in order for those statements to be true. X is going to be different for each one. 2 times something gives you 1. Do you know what that is? Okay, 2 times something gives you 1. Good. If you have 2 halves, they make a whole, right? So in this case, x is equal to 1/2. What about this one? 3 times something gives you 1. So if you have 3 thirds, are you seeing a pattern here? Good. What about this one? What does x have to be for this one? Did you say 9? Good. So you're actually doing algebra in your head. Isn't that cool? So that's fantastic. Okay, good. What if I said x over 6 equals 1? What would you tell me x is? X over 6. So we write that first. X over 6 equals 1. Oops, there you go. X must equal 6. Good. Okay, you're good at this. See, I told you. So perfect. All right, take a look at the ones in the bottom of the page. So there's 4 questions at the bottom of the page. The first one, let's get my questions back up here. Ah, where did it go? Okay. Oh, I see it. It's underneath my papers. There we go. Okay, so take a look at the ones in the bottom. If I were to say the sum of a number and 10, what would you write down? The sum means plus, of a number and 10, okay? So sometimes if the word problems don't make a lot of sense, just stick something in. So if I said the sum of 5 and 10, what would you write? Don't write the answer. Write what you would do to get the answer. Okay, so this would be 5, or this 5 plus 10, right? But it says a number. It doesn't really say 5. So what we're going to do is just put x in for that, a number and 10. Yeah, this is page 1 of the handout. Good. Okay, so let's see. We'll do this one. Today is 10 degrees warmer than yesterday. Do we know what the temperature was yesterday? No. So that's our unknown, okay? And unknowns can be any symbol that you want. It could be lowercase English alphabet. It could be uppercase. You could use Greek letters. You could use anything you want, but you just want to make sure you understand that that's the symbol you're using. Okay, so initially when we start with algebra, we start with X, Y's, and Z's. We'll start with A, B, and C's sometimes. We don't give you any really weird ones until you get into algebra 2. So today is warmer, or is yesterday warmer? Today is warmer. By how much? 10 degrees. So this thing looks the same, doesn't it? Okay, good. So 2 different scenarios, same math expression. Good. Twice the difference of a number and 4. What do you do with that? Okay, so again, if this is confusing to you, just put a number in for the word number. Put in like, I don't know, 10. So twice the difference, so twice is 2. Difference means subtract. Of is multiply. Okay, so twice the difference. The difference is the number here, say we said 10 minus 4, so we're going to put x minus 4. Okay, so the idea of just substituting a real number in for the number, for the variable, can just get us used to thinking about variables. But then you got to put the variable back in. Twice the difference of, so the difference is the number and 4. Good. All right, you do these 3. Ready? I'll give you a little bit of time. I'll read the first one in case it's a little blurry. It says, she made 3 times more cookies this time. Okay, at this time compared to when? Last time. So she made 3 times more cookies. Okay, the next one says 3 plus twice a number. If it wasn't twice, could you do it? 3 plus a number? Okay, now put the twice in. 3 plus twice a number. Okay. And the last one, I had $100, so I bought 7 pizzas. That's what we do with our $100. I had $100, so I bought 7 pizzas. Okay, so you had 100. The pizzas are going to cost something, so are we going to add or subtract? Okay, so for the first one, here, let me move myself. So for the first one, she made 3 more cookies than last time. Here's last time. We don't know how many it is, but this time she made 3 more. Okay, 3 plus, if it was just 3 plus a number, it would look like this. But it's plus twice a number. So I didn't leave enough room, did I? So I'm going to say it's twice a number. Good. I had 100 pizzas. No, wait, I'm sorry. I had $100, and I bought 7 pizzas. It's going to cost me something. I don't know how much the pizzas cost. You can put P for pizza if you want, or X. It's up to you. All right. How was that? You feeling okay about these? Okay. Especially if we do them together. Okay, great. let's go ahead and take a peek at page number 2. And again, if you don't have your handout, don't worry. Just follow me, and you can borrow mine. Okay, so at the top, this is the same information that's in your workbook, so it goes together really well. Okay, so let's take an example problem. Let me show you what it's saying up there. I'm going to give you an expression, and I'm going to say, for this expression, I'm going to tell you x equals 4. Can you tell me the value of this expression? So every time you see an x, you're going to put the number 4. So it's going to look like this. 2 times, and now instead of an x, we have a 4. Okay, and then I'm going to say minus 3. Do you remember our order of operations? We do the parentheses first. So 4 minus 3 is a positive 1, so it's going to be 2 times 1, which is 2. Okay, good. Let's do another one. I'm going to give you this one, minus 5 times x plus 7. Let's evaluate it for when x equals 2. Okay. Okay, so what does that mean? Every time you see an x, you're going to put the number 2, and that's what goes in there. Okay, so let's do it together. So you do this part slow. Minus 5 times 2 plus 7. So you rewrite the whole thing again. Don't try to do it in your head. Chances are really high you're going to make a mistake, and I'll show you why in a second. So this goes first because it's multiply. Minus 10 plus 7. The 10 is bigger, so we know the negative sign starts. And then the difference between 10 and 7 is 3. The answer is negative 3. Good. Yeah, when you do these in your head without doing these handwritten steps out, we tend to make mistakes. Let me show you. If I said 12y minus 3, and I said y is 1, that didn't work. 12y minus 3, and I'd say y is equal to 1/3. Can you do that in your head really quick? Just do it really, really fast. What do you get? And then we'll do it the long way. Don't take all day, just take a stab at it. And we'll see. Okay, now let's do it slow. 12 times 1/3 minus 3. Do this first. 12 divided by 3 is 4 minus 3 equals 1. If you got it right, fantastic. If you didn't, don't worry. That's why we do them out longhand, especially in the beginning. Because when we start having negative signs, which we are right now, it's easy to make mistakes. Okay, can you do this one in your head? See if you can get the right answer. Go for it. Don't write anything down. Just tell me what it is. And then we'll do it together and see how close you got. Okay. So far, no one's given me the right answer. Oh, no, I'm sorry, Eden. You're the one person. Okay, so let's take this slow. So x is minus 1, so minus 2, minus 1, minus 5. Okay, so there's our minus 1, went in for the x. So we evaluate this first. We get a minus 1, minus 5, that's a minus 6. So we have a minus 2 times a minus 6. Minus times minus equals a positive. 2 times 6 is positive 12. Okay, 125, I'm guessing that's a typo. Okay, good. So you want to take it slow. So now it's your turn. Ready? You do this one. Okay. Go ahead and write it out and tell me, what do you get when you substitute x is equal to negative 4? Okay. How many of you got that? Awesome. I do want you to learn how to get it right in your head. And in order to do that, we write them out in slow, easy steps first. Because when you're in Algebra 2, I'm going to expect you to be able to do stuff like this in your head. So if you're already getting it right in your head, fantastic. If not, don't worry. You're right there with me. I make mistakes all the time. And so that's why I always write things down. Okay, page number 3 looks like this. And we're going to evaluate an expression, but this one has x's and y's. You see that? Okay, so we're going to do this one first. So I'm going to say for x is equal to -1, y is equal to 0, let's evaluate 2x plus 3y. Can you tell me what that equals? Okay, so wherever there's an x, you're going to put that. Whenever there's a y, you're going to put that. Okay, so it's going to be 2 times -1 plus 3 times 0. So this expression equals -2 plus 0. It equals -2. Yeah, don't forget your negative sign. Good. Okay, you want to try another one? Okay, now you do this one. So I'm going to say it's the same expression, 2x plus 3y, but this time x is equal to, let's make it 2, and y is equal to -3. Okay? So you tell me, what does this expression equal? Okay, go ahead and put it in the chat when you're ready. Okay, I've already gotten like 6 different answers. So again, go slow. Go slow when you're doing this. I've got kids going, wait, I'm going to recheck. Okay, let's do it together. Okay, so 2 times 2 plus 3 times -3. Don't drop your minus signs. All right, so this is going to be 4 plus, this is going to be a -9. Okay, so we have a positive and negative. So the 9 is larger, it's going to be 9. The difference between 9 and 4 is 5. Wow, I got a lot. I've got about 15 different answers that got submitted. So yes, welcome to algebra. It happens to everybody. Everybody loses, drops minus signs, forgets to multiply by something. It happens to us all. So remember I told you the story about slow is smooth, smooth is fast? So that's what we're doing here. This is the slow is smooth. Okay, I'm going to give you 2 more, and I want you to tell me what your solutions are, okay? Here we go. This time we're going to use the second equation, which is this one, 5x minus 2y. Okay, for scenario number 1, I want you to tell me, what do you get when x is -2 and y is 1? Scenario 2, you're going to tell me this when x is equal to -7, y is equal to -3. Okay, so go ahead. So first equation, this is the same equation for both. Okay, so in the first case, you're just using these values for x and y. In the second case, you're going to use those values. Okay, same equation though. Okay, take your time. Take your time. You can just give me both answers in the same chat if you want. Okay. I wish you could see all the answers coming in. There's no 2 answers that are the same. Okay, I want you to go slower. It means you're going too fast. Go slower. Okay, let's do it together. Let's take that first one. Here, do you have this written down so I can move this? Yeah, go ahead and get this written down. Okay, it happens to everybody, so don't worry. Okay, so we're going to do this one first. So 5 times -2 minus 2 times 1. So -2 goes in there, 1 goes in there. So now you evaluate. This is -10 minus 2. Okay, and that's -12 for the first one. Okay, second one. So this is going to be a 5 times -7 minus 2. I think this is the one that's tripping people up. That -3 multiplied by -2. Let's see. What do we get? This is -35. Minus a minus becomes a plus. What do we get? plus and minus. 35 is bigger than 6, negative. And this becomes 29. Okay, do you got it now? Yeah. Forgot to minus my answer. All right, I'm glad this is happening. Here, I'll leave that up because it's really common. So especially when you do your homework, so you don't have to keep redoing the problem over and over, go really slow. Are you seeing how powerful this is? Slow is smooth? Yeah, we're in the slow is smooth part. And I know it's a little frustrating because like, I got it. I just did that. Ugh. You're gonna have problems that are gonna have X, Y, Z's, and even more variables. And it's gonna be harder and harder to keep track of everything in your head. So that's why I wanna get into the practice of writing things down. Okay, I think you're ready for page number 4, don't you? Okay, let's go ahead and turn to page number 4. Good job, by the way. Go, grab us a little sip of water, grab a little sip, and let's move on to the next part. Okay. So page number 4.